All right, guys, let's do this. Let's look at the first two. Then I'll give you a little more time on the third one. Let's see if we can make it to the Hobbit problem. So this one, sine we know already. I'm just going to put it down here just for completeness. What's cosine going to be? What's the definition of cosine? It's 1 over 1. X over h. So cosine is going to be rad 13 over 7. Right? Is that cool? So if I give you a triangle with two sides and I ask you to find, okay, you should go like, oh, okay, cool, sweet. All I got to do is Pythagorean theorem and then set up the ratios. What about tangent? Yeah, it's y over x. So it's negative 6 over rad 13, and then you should rationalize it. So there's tangent. Cosecant is nice. I basically just gave you that one. What's cosecant going to be? I know sine is negative 6 over 7, so cosecant is negative 7 over 6. So cosecant is just flip the sign. What about secant? Secant, you just flip the table. No, you flip the cosine, right? So I get 7 over rad 13, and then I need to rationalize that. I need to be able to write. That'd be awesome. Okay. And then cotangent is just flipping tangent. So I'm going to take its original look. I'm going to make it negative rad 13. Just flip it. Negative rad 13 over 6. Okay, I like it. So again, that's the most bare minimum thing. It's just to know what sine, cosine, tangent, what they all reference. Which sides do they reference? Because that's all they freaking are, is making ratios. That's all they are at the heart of it. Okay. So this one here, very often on a quiz or a test, I'm going to ask you to draw a picture and indicate the reference angle. So I really want you to show me what your thought process is. So 12 pi over 6 would be all the way around. We stopped pi over 6 short. So there's the reference angle. What is sine where I stopped there? Which I'm in the fourth quadrant. What's sine there? Positive or negative? Negative, because sine likes y. Y is negative there. So it'll be negative sine of pi over 6. That's what this is. This is the same thing as negative sine of pi over 6. And what is sine of pi over 6? Say again? 30. Okay, pi over 6 radians is 30 degrees. But what is sine of pi over 6? Yeah, sine of pi over 6 is 1/2. So this is negative 1/2. Do you guys understand? So I could ask you a question about change this from radians to degrees or degrees to radians. That's not what this is. This is saying, what is the sine of this angle? It's trying to be a 2, poor little dude. What about this guy? I go back a full rotation, right? And then how much more? I go back 360 degrees. That's a full rotation. How much more do I go past that? 120. So I stop how short of 180? 60. So my reference angle is 60. I really want you to see, was that difficult what I just did? Every rotation is 360. So 480's got a rotation in it. And then I go a little further. Right? Now I know my reference angle. I know what quadrant I'm in. Is cosine positive or negative where I ended up? Cosine likes x. So is x positive or negative? Back there is negative. So I know this is going to be negative cosine 60. This question is the same as this question. That's what we just figured out. It's negative, and the reference angle is 60. what is cosine of 60 degrees? Yeah. And again, what do you think to yourself? And again, I don't know if you believe me. I don't have this shit memorized. I don't. When I said the first one, what was the first one? Sine of 30, sine of pi over 6. I had to think of myself real quick. All right, sine likes y. 30 degrees is closer to x. It must be the smaller one. It must be a half. Cosine likes x. 60 is far from x. It must be the smaller one, 1/2. So it's negative 1/2. What about this? What is that really close to? The top would have been better if it was what? Negative 12, because that would be negative 3 pi, right? So that would be negative pi, negative 2 pi, negative 3 pi, and then how much past that did I go? So recall that this is negative pi, another negative pi, another negative pi, well that's 3 pi, that's 12 pi over 4. So I went another pi over 4 past that. Right? Okay, let's do a few things. So this will be, and cosecant. What is that related to?
One of the sign.
Sine. And what sign in that quadrant? Positive or negative? Yeah, I'm up in that quadrant. That's where y is positive, so sine is positive. So this is the same thing as cosecant of pi over 4. So I figure out if it's positive or negative, and I figure out its reference angle. That's why you only have to memorize the first quadrant values. That's it. Because then the reference angle is from the first quadrant. And you just told me that cosecant is 1 over sine, right? There you go. So what is sine of pi over 4? Rad 2 over 2. So what is 1 divided by rad 2 over 2? Say again, sorry?
Rad 2.
Eventually, yes. But it's 2 over rad 2. Right? Which is 2 rad 2 over 2 if I rationalize it, which is rad 2. Woo! Okay. Maybe. Do you see right here this key? If I get one of these other 3 functions that are not the base 3, I just make it 1 over its associated 1, because I have those memorized. I don't have cosecant memorized for sure. So what about this guy? 330 degrees. I stopped how much short of the y of the x-axis? 30 degrees. All right, so this will be, oh shit, where am I? There I am. And down here, what is sine and cosine? They are opposite signs, so this will be negative tangent of 30 degrees. Now, I don't have tangent memorized. I'll try to tell you what I do have. If you still have that big grid we made at the beginning of class, tangent is going to be rad 3, or it's going to be 1, or it's going to be rad 3 over 3, or undefined, or 0, right? That's the other extremes. Are you guys kind of with me? Tangent is sine over cosine, correct? So tangent is big when sine is big. Tangent is small when sine is small. Because tangent is equal to sine divided by cosine. So at 30 degrees, is sine big or small? Small. So tangent's going to be the smaller option, which is rad 3 over 3. Now if you didn't follow what I just did, let me give you an alternate way to do that. So we know that this is negative tangent of 30. Let me do this. Negative tangent of 30. That is negative sine 30 over cosine 30. You can always do this for tangent. What is sine of 30 degrees? Oops. I'm like zoomed away the hell in. What is sine of 30? Poor little sine. 1/2. What is cosine of 30? It loves it there. It's close to its home. So it's rad 3 over 2. The over 2's cancel. Rationalize. I get negative rad 3 over 3. Right? Okay. But again, do you see how everything depends on you knowing sines and cosines? If you commit sine and cosine to memory in some way, you can build everything else that you need. It's crazy. Okay. Yeah, we're coming up on, I don't know if anybody did any of these quite yet. What I would do for this, see how my angle is here? But we know, what is this angle? What's it gotta be?
What's it?
47, why?
180?
Because so they can all make 180. I love it. So this isn't too hard to see, but just to turn this over, isn't this the x side? Right? And isn't this the y side? And this is the hypotenuse. Okay. So let me just do one of these problems, and I'll let you do a few more things here. Let's see. How would I figure out? So I know this side is 24, right? What trig function could I use so that I can get this? That would relate all three of these things. What relates x to h? Cosine. So the cosine of 43 has to be x over h. Can you solve that for h? Ache. That h will be 24 divided by cosine of 43. And this is where you need your calculator, right? Do I even have my calculator? Yeah. So I have to make sure, number one, I gotta make sure I'm in degrees. That's gonna suck so much. You gotta be really careful because the problems are gonna go back and forth between radians and degrees. So before you do anything, make sure you're in the right mode. So I could do 24 divided by cosine of 43, and I get 32.82 roughly, right? Now, what makes sense about that so far? Let me see if you guys are cool with this. If I got 21 for that, how do I know I'm wrong? If I got 21 instead of that. Yeah, it can't be smaller than any other side. It's got to be the biggest side, right? So at least check that. At least make sure you're on the right track. How do I get this last side? I could either do Pythagorean theorem or I could do sine, right? The same way we did cosine to get this side. Sorry, I can use sine or tangent, right? But I'd rather just do Pythagorean theorem. Once I have two sides, I can just do Pythagorean theorem. So how would Pythagorean theorem look? I really didn't give enough room here, did I? I'm so evil. You guys have paper.
I have a quick question.
Yes?
Could you also use tangent?
Yeah, that's what I said. So you could use tangent of this to be y over 24. I love it. Right? In fact, I mean, that would be a little cleaner, to be honest, but I don't know what you guys would choose. Pythagorean, or you probably would choose Pythagorean, I would think, because that's what you're more familiar with. Well, let's try to do it both ways. Let's see what we get. So if I do Pythagorean, it'll be 32.82 squared equals 24 squared plus y squared, right? And then I can solve for y. So let's do that very quickly. 32.82. Actually, I'm just going to use, nah, screw it, Jeff. Minus 24 squared. That's y squared. And then take the square root. So that's y. About 22.39. And why does that make sense? Real quick. Which one of these angles is bigger? Obviously, this one's bigger, correct? So its mouth should be wider. So this should be bigger than this, and it is. Does that make sense? If that angle's bigger, this side should be bigger than this side. And it is. So again, you can kind of check yourself as you go. Is it making sense? I could solve for y a different way. Like Christian just said. Christian said tangent of 43 would be y over x. So y would be 24 times tangent of 43. Let's see what we get if we do that. 24 times tangent 43. I get the same thing basically, right? Why is it not exactly the same? Because I rounded this, didn't I? But I get basically the same thing. Is that cool? So you're completely right. There's more than one way to get that last side.
How did you get 47 degree?
What, here? This is 90, right? This is 43, so
Oh.
this has to be the rest. Yeah. Okay. Maybe. Okay. So, I mean, the other two work basically the same way. You just, like, the last one's probably the easiest because this is already in the base. So this is my y, this is my x. Here, this one's here, so what's this angle? Sorry, you can't see shit, sorry. This one's here, so what's this angle here?
25.
Yeah, 25 degrees. So then I could just use this angle, and then this would be the x, and this would be the y, because that's in the base. You guys see that? Or I could use this angle, and call this y, and call this x. It doesn't matter. The trig will work out either way. Maybe. So let's do this one, and then we'll call it a day, I think. Let's see. So, if I use this angle, this is the x piece, this is the y piece, because if that's in the base, x, y, that makes sense, right? So how would I get, let's see. How would I get this side? I know the hypotenuse, and I know this angle. What would relate those things? X in the hypotenuse. Say again? Cosine, yeah, cosine. Cosine of 25 is x over the hypotenuse. And then I can just solve for x, right? I would multiply the 40 up. And then I just throw that in the old calculator. 40 times cosine of 25. I get 36.25. So this should be a relatively large side. It should be pretty close to this because this angle's so tiny and this angle's so big. So it makes sense it's really close to 40. And then I have two ways to figure out y again. I can either use sine, or I could use Pythagorean theorem, right? You guys with me a little tiny bit? A little tiny? Not really? Screw you, Jeff? Okay, so I'll tell you what, we'll finish this up next time. I really want to do the hobbits problem, right? Like, why didn't the eagles just take them straight there in the first place? But we won't figure that out.
This one? Put it in there because I found like one of the low power.
Oh, what's the base? So it's log base 4 of this sentence equals 1. So it's 4 to the first power equals this. Right? That's how I rewrite a law. Son of a bitch, that's right.
Thank you.
Okay. Son of a bitch, I'm in. Sure.